We're going to continue talking about this supervising the sky situation to kind of lead into converting back and forth between polar coordinates and rectangular coordinates. All right, so we're going to go to number 3. Hot air balloons are not allowed within 20 miles of an airport for safety reasons. If a hot air balloon is identified on the radar screen, police must be notified of its location. The police must be given rectangular north, south, east, west directions in reference to the control tower to find the possible offender on their GPS. If a hot air balloon appears on the radar screen at the point shown, what coordinates should the air traffic controller give the police? So, how many miles north or south, and how many miles east or west is the balloon from the tower? All right, so here's our balloon. If we were looking at the angles, that angle is going to be 7 pi over 6. And then for the R, if we count by fives, 5, 10, 15, 20, 25, 30, 35. So right now it's 35 miles away, so it's not breaking any rules. But we're going to go ahead and get the police ready just in case. So you can tell that this balloon is west and south of the air traffic controller tower. So let's start with west. All right, and when we're talking about west, we're talking about the x coordinates. And so if you guys remember our rules from before, that the cosine of theta is equal to x over r. And so in this case, it would be the cosine of our angle. We know theta is 7 pi over 6 is going to be equal to x over, and we also know r. We know the hot air balloon is 35 miles away. All right, so just remember that if something is in the denominator you don't want there, you can multiply by it. So x is going to be equal to 35 times the cosine of 7 pi over 6. All right, now I am going to use a calculator to do this. We are going to do a whole lot of stuff without the calculator today, probably most everything, but I just want to do this real quick. All right, so that's going to be the x coordinate is negative 30.311. So you would need to tell the police officer that it is 30.311 miles west. All right, and then looking at the point, we know that it is south. So south is going to be the y. And so if you hopefully you remember from before that the sine of theta is the y over the r. So in this case, the sine of 7 pi over 6 is equal to the y over 35. So y is 35 times the sine of 7 pi over 6. All right. All right. So, and we can tell the police officers that it's 17.5 miles south of the tower. All right, the hot air balloon continues to move. By the time the police are able to catch up to the balloon, it is located 13 miles east and 15 miles south of the airport. Does this balloon violate the 20-mile limit? Okay, so let's figure this out. So we need to figure out how far away it is. And to do that, we're going to kind of use a version of the Pythagorean theorem. We also used this before when we were finding r. So r is going to be the square root of 13 squared plus 15 squared. And that's 19.849 miles. So it's drifted too close. That's why they start keeping an eye on it. So yes, this is a violation. All right, and then finally, what angle should be used to locate the balloon's new location on the radar grid? So this time we need to find theta. And what we have is x and y. So the third little rule we learned about trig values with x, y, and r is that the tangent of theta is equal to y divided by x. So in this case, the tangent of theta is equal to, now we have to be careful. So because we are south, the y needs to be negative, and then east is going to be a positive x value. And this one would require a calculator anyway. So what we do, hold on, one more thing. So what we would do, if we know what the tangent is, we want to find the angle that has that tangent. The angle is the inverse tangent. So theta negative 0.857 radians. Right, so we're going to do all that same stuff with our notes. All right, so picking up on the front of the second page, you can see how rectangular and polar coordinates are related using trigonometry. So going over and up, you can get to the same point. It's just taking a direct angle to it. All right, so if we have polar coordinates and we want to convert to rectangular coordinates, the x is kind of like what we just did. The x is going to be equal to r times the cosine of theta, and the y is going to be equal to r times the sine of theta. Now, I like to just go ahead and do the graph. Sometimes when you do the graph, you don't even need to do the formula. I am going to practice it anyway, but sometimes you can figure it out without the formula. All right, so let's look at example 4. We have the polar coordinates 2 pi, which means it's 2 units away, is at the angle pi, which would be the point right here. It's 2 units away. I bet you could guess what that is in rectangular coordinates, but let's just go ahead and go through the steps. All right, so polar coordinates, you're going to have it. Oh, wait, hold on. Sorry, we can guess what it is in rectangular coordinates. So rectangular coordinates, the x is going to be equal to 2 times the cosine of the angle. All right, now you're probably going to want to pull out your unit circle, or maybe you have this memorized. But if we look at the unit circle, we look at theta. The cosine is going to be whatever the x coordinate is there, and the x coordinate there is -1. So that's going to be -2. All right, and then for the y, it's going to be 2 times the sine of theta. right, so if you're looking at your unit circle at pi, the sign is going to be the y coordinate, and the y coordinate there would be 0. So our rectangular coordinates for that point are -2, 0, which you could have figured out on your own just by looking at the graph. The next one, we can't. We have to do all the things. But I do want to do a little graph. All right, so we're going to be 4 circles out, and then the angle is 5 pi over 3, so it would be somewhere around like that. Okay, so to figure out the x-coordinate, we're going to do 4 times the cosine of 5 pi over 3. All right, again, you're going to want to look at your unit circle at 5 pi over 3. We want, for the cosine, we want the x-coordinate. The x-coordinate is 1/2. So x here is going to be 2. All right. For 5 pi over 3, for the sine, we're going to look at the y-coordinate. And the y-coordinate here is going to be negative square root of 3 over 2. All right, so that 4 over 2 is going to reduce to 2. So it's going to be -2 square root of 3. So those are the rectangular coordinates at that point. You're going to go over 2, and then you're going to go down to square root of 3. And so hopefully doing the little graph helps, because if we have it in quadrant 4 and when you do all the work, you don't get something that makes sense where you go over and down to get to negative, then you did something wrong. So it always helps to do a little graph. Okay, and then for C, this one's a little more difficult to do the graph. All right, so we're going to go, this time we're going to go -3 and rotate 7 pi over 6, which should lead us about right there. All right, so x is going to be -3 times the cosine of 7 pi over 6. And then if you look at your unit circle, cosine of 7 pi over 6 is negative square root of 3 over 2. So that's going to be, this one's going to be kind of messy. It's okay. There's nothing we can really simplify except we know a negative times a negative is a positive. Okay, and then the sine of 7 pi over 6 is going to be -1/2. So that's going to be 3/2. All right, so quadrant 1, both coordinates are positive, so we're probably right. All right, we're going to have to do it the other way as well. So we are going to have the rectangular coordinates. We're going to have x's and y's, and we're going to change them to r and theta. And so to find r, you basically use the Pythagorean theorem. I like a little bit of a more simplified form. That is, r is the square root of x squared plus y squared. And then for tangent, we're going to use the fact that we know the tangent of theta is y over x to figure out what theta is, using the y and the x. Again, I'm going to graph it because, I have to see it for it to make sense. Okay, so if I have the rectangular coordinates, -2, 2, so that means left 2, up 2 is going to be the point right there. Let's figure out what r and theta are. So r is the square root of -2 squared, which is 4, plus 2 squared, which is 4. This is the square root of 8. It's possible we could just leave it like that, or you could simplify it to 2 square root of 2. All right, and then to figure out theta, the tangent of theta is equal to the y over the x, or In this case, it's -1. Now I know whenever the tangent is 1 or -1, it's going to be one of the pi/4 angles because those are the ones that have the slope of 1 or the slope of -1. So what I'm looking for is the pi/4 angle that is in quadrant 2. And the pi/4 angle in quadrant 2 is 3 pi/4. All right, so this takes a little bit more intuition and less just like straight doing the math. You're going to have to think about this a little bit on your thetas. So I do think it's essential that you do the graph. All right, let's look at the next one. So we are going to go right 1 and down square root of 3. Okay, so r is going to be the square root of 1 squared plus negative square root of 3 squared is just going to be 3. All right, and then for the tangent of theta, that's going to be the y over the x. So we want to know which angle, and this angle needs to be in quadrant 4, has a tangent of negative square root of 3 over 1, which means that if I take the y and I multiply it by the reciprocal of x, that is what I'm going to get. And that corresponds with 5 pi over 3. Okay, so over 0, down 5. Now, I already know what the answer to this is. So I know that the distance, if I went down 5, the distance that is away from 0 or the pole is 5. And I also know that angle there is 3 pi over 2. So I could skip it. Like, I don't have to do all the things. If you wanted to practice doing all the things again, r is equal to 0 squared plus -5 squared, the square root of that, sorry. So r is 5, like we already knew it was. And then the tangent of theta is equal to y over x, which is undefined. All right, so undefined there at that point. If we did the y divided by the x, there's 2 places where tangent is going to be undefined on this graph. It's going to be up here and down here. We know we want the one down there, so it's 3 pi over 2. So that unit circle is definitely going to be helpful when you do this lesson.